Hello everyone. So this is my demo video for the project based open to all internship by Ineuron. So let's get started with my IPYNB file. First of all, I had imported the all important libraries for my project such as pandas for the reading the CSV file purpose, seaborn, Matplotlib and coupling plotly, offline plotly and simple imputer for the visualization and data cleaning purpose. So there are five data sets for the NBA Draft 2012, 2013, 2014, 2015 and 16. First of all, we had concatenate all these data sets and made a new data set called DF. This is the archetype of my data frame. Now, first of all, we are going with the data cleaning with analyzing the features. First of all, we are going to handling our missing values or the NN values. To handle the missing values, I had imported the simple imputer mean, simple imputer median, simple imputer mode. Now, here is some of the info of my dataset. The player dataset having 306 null values, year having 306, and the height with no shoes having some null values. Here is the analyzing of the null values. The draft pick having 91 null values, vertical max having 49 null values. So the columns which having the null values are draft pick, vertical max reach, vertical snow step, and so on. So we are going to apply the mean, mode and median by the use of simple imputer library in each of the column one by one. So first of all, in the draft pick column, we are finding the unique values and then we are finding the value counts. So 9.0 comes 5 times. So it is a mode of frequency of each and every elements. Here is a count plot for the elements. So after plotting the count plot, we had find that we are going to apply the mean. So by using the simple imputer technique, we use the mean and reshaped our data from -1 to 1, and here we got the 0 null values after applying the mean and converted the float values into the integer type values. Now we are going with the vertical max column. In the vertical max column, there is also an NN value and the data type of the vertical max is float. Now after finding the value counts, frequency of each and every element, we find that the 35.5 comes 22 times. So after analyzing the vertical max, we found that we are going to using the mode in place of NN values. After applying the mode, we have a pie chart to analyzing the vertical max that 23% of the total vertical max having the value 71. Here you can see label with 33.5 having value 71. Then we are going with the vertical max reach column. Here we are also find that 138.0 comes 20 times. So after analyzing the vertical max reach column, we are come with the result that we are going to apply the mean. So after applying the mean, we come with the maximum number of counts which having the mean value. So after vertical no step reach, here also we had applied the mean, vertical no step column, mean, weight, bench column. Here because bench column having the 50% data as null, so we dropped this column. Here you can see that the count of the bench column is 149 and our shape of the data is 306. So about 50% of the data having null value. So the best approach is to drop that column. So here we have dropped that column. Now we are applying the mean on the agility and sprint as well. So after cleaning the data, we having a cleaned data set. Now we are going to apply analyzing the data by the statistical analyzation. So here is the describe having the count value of year, draft pick height, and mean value, standard deviation, mean 25 percentile, 50 percentile of the data, 75 percentile of data, and maximum. So let's go with the analyzing our data. Our data frame having the column these, and by using the I plot, coupling I plot, we are having the graph like this. For the players, these are the object types. So for the graph of the players is a little bit different with the integer values. Here you can see that the sprint column having the maximum value count. If we apply only the year from here, you can see that you can see that the year value count of the year has increases like this. If we apply the draft pick, you can see that the value count for the draft pick has increases like an increases and decreases like a heartbeat. So here is the box plot for the different columns. For the player column having the median of Jordan Bench Cardi, having the upper extreme as the player name Joe QI, having the lower extreme player name Desan Thomas. Here is the count box plot for the year. Here is the box plot for the draft pick having the median of 7. Here wingspan median of 79.5. As you can see that the box plot of some box plots are overlapping. Means lower extremes are approximate same for these 4 columns. So IQR range is approximate similar for these 3 box plots. Here the year wise player picking means drafting. You can see that in this bar chart, the draft picking in the year of 2012 is minimum, having 29 draft picks, and in the year of 2016 the draft pick is increased and having draft picks of 20 and draft picks of 43. Every year the player picked goes high. In 2016 the drafting is more as compared to 2012, 13, 14 and 15. Now we are going to analyze the height without shoes and draft picking of the player. Here I had made the scatter plot, and inside the scatter plot you can see that as the height of the player increases, the draft picking is somehow constant. Here you can see that the most of the players having the constant value of something 29, draft picking of 29. Now we are going to analyze the height with no shoes and with shoe. As you can see in the graph that as the height without shoe increases, the height with the shoe also increases, and whereas there is a small outlier as the height with shoe 81. You can see here the small outlier, not but big. Now we are going to plot the box plot for the height with shoe. Here you can see that there are 2 outliers at the point of 1 below the 70. Now we are going to analyzing the wingspan with height with no shoe. Here you can see that the height with no shoe and the wingspan are linearly dependent and increases. Here is the reg plot. You can see that there is a best fit line which shows that these two data series are linearly dependent and increases. Now we are going to analyzing the height with weight and weight. Scatter plot for the height with weight. Here you can see that the height with weight is increases as the weight increases. Now we are going to plot the box plot for the weight. You can see that the median for the weight is somewhere 215, and the IQR range is in between 200 to 235 approx. So there is no outlier. As the height of the player increases, the weight also increases. Now we are going to analyzing the weight and body fat analysis as per height. We are plotting the body fat with the height. As you can see that as the weight increases, the body fat also increases. Here is the line plot. You can see that the body fat and the weight are different enough, means these both columns are not dependent on each other. The values of weight is much more than the body fat. The body fat, you can see that the body fat is somehow constant for every player. Somehow is in between 8 to 6 to 12. Now we are going to analyzing the agility with the bar plot. You can see that the agility with the agility bar plot, the maximum agility is for this. Now we are going to plot the scatter plot for the height with no shoe and the weight and the size of the bubbles with the agility. As you can see that the size of the bubbles for every bubbles are same, so we can say that the agility are somehow constant for each and every player with the weight and height. And you can also see that the height with no shoe and the weight are linearly increasing in the scatter plot. Now as the agility is somehow constant, so we are going to drop the agility column. No need of agility column in our survey. Now we are going to analyze the sprint. Here you can see that the height with no shoe and weight with the size of the sprint, means the as big the size radius of the bubble, as more the sprint is. It means you can see that the sprint is somehow constant for each and every player with the weight and height with no shoe. Now we are going to analyze the scatter plot for the vertical max and height with no shoe for each and every player with the size of the bubble as a sprint. Now you can see that the height with no shoe is linearly decreasing with the vertical max, and the sprint is somehow same. Sprint is been between 3 to 4. So here if you apply the reg plot with data with the estimator as mean, you can find that the height with no shoe is linearly decreasing, and there is 2 points which are differ from their means. Here you can also see the joint plot for the same. Now we are going to analyze the relation between vertical max and vertical max reach. The above graph shows that only one person having the vertical max with vertical max reach both. Most probability the person are in between 130 to 245 vertical max reach. There is a single person which is an outlier at the 25 of vertical max. Now we are going to analyze the relationship between the hand length and hand width. You can see there is a linear dependency with increasing in between the hand width and hand length, and there are 2 outliers. One, another is here. Now, relationship between wingspan and sum of hand width and hand length. Here you can see that there is a one outlier with the value of -1, which are completely differ from the hand length. Here are two outliers. After plotting the bar plot, we find that there are three outliers, one at upper extreme and two are in upper extreme, three below the lower extreme and one at upper extreme. IQR is in between 50 to 20. Here is the weight with the year analysis. You can see that from the year 2012 to 2013 the weight increases, then 2013 to 2014 weight is, and so on. Then body fat with year, you can see that the body fat in the year of 2012 to 2013 is decreases. Then 2013 to 2014 approximate decreases, means approximate constant. Then 2014 to 2015 increases, something increases, then decreases as well. Now in analyzing the 3D plot for the body fat and of the player with the year, you can see that there is a linear decreasing in the body fat with the year. And the above graph shows that a single person in 2014 having the maximum body fat of 16.3 named LaQuentin Rose. As you can see in the figure, there is a guy here. No, where he is? Okay, yeah. And now relationship between the vertical max reach and player. You can see that the relationship between the vertical max and the player are somehow constant. Scatter plot. A player named Chris Dunn having hand length of -1 at vertical max of 35.5. Here you can see that Chris Dunn having the x is equals to 35.5, y is equals to -1. Now analyzing of with the sprint with the player with the ear, you can see the sprint decreases with the ear. Now 3D plot for the wingspan standing reach player. Now surface plot with weight and body fat, height with body fat. Now here is the spread graph. Hand length in the spread graph, we can see that the hand length is almost constant. Hand length decreases sudden between 25 to 35. If I plot only the height with no shoe, vertical with no shoe, here you can see that there is a sudden decrease in the hand length between 250 to 300, which is 278, having weight or hand length of -1. Now here is a parallel graph. You can see in the parallel graph that it take all those categories as unique values less than 50. Below graph shows that the standing reach is maximum at 115. As here you can see that the maximum standing reach is 215, and 215 in the year of 2013, which having vertical max of 29, vertical max reach of 114, vertical nose step reach 140, hand length and hand width of 9.5, 9.7 and 10. Here you can see the density plot for the year with the sprint. Here you can see that the sprint having more density of 5 in between 3.2 to 3.4. Now is a contour plot. You can see the contour plot is similar for as the density plot and the box plot. The height is maximum as the standing reach of 101. Here you can see that the standing reach of 101 with the sprint is maximum, and the probability of finding the player is more at maximum height. As you can go away from the contour plot, your height is decreasing. If you analyze this figure in the 3D plot, you can find that the higher the density, higher the height and lower the density, means lower the height, and if we are going away from the contour plot, we are going below the height. Now here is the violin plot. Violin plot is somehow similar with the box plot. For the vertical max, there is a one outlier. For the vertical no step, this. Now hand width and hand length, violin plot. Then here is the empirical commutative distribution. By the commutative distribution, we can find the probability of finding the finding the player in for the vertical no step changes from the 0.5 to 0.7. Here you can see that it changes from value of 35.5 to value of 36. Now same for this. Now here is the bar plot for the wingspan standing reach. You can see that the maximum standing reach is at 82 of wingspan. Here is the really line plot for the vertical max reach, no step reach, etc. is the pair plot, and is the heat map. Thank you. And we are using the Tableau. So here if we Plotly and Tableau, so here if I go with the Tableau, we find that with the year the hand length, summation of the hand length is increases. Now if we want the hand length and hand width both, we find that the hand length and hand width both are increases with the years. We also change this with the line, with the now we are going to take the players. Here you can see that the hand length increases with for each and every player, increases and decreases, but in between but for the Austrian dares there is no hand length. There is a gap in between the for the Austrian dares, and for the black griffin there is also a gap. So here we can use the Tableau. We also uses the Plotly for the visualization purpose. Here you can see the height without shoe for each and every player. If we want the bar plot, we can also draw the bar plot by clicking on the bar. We can also change the column, such as we are going to apply the draft pick. Here you can see the bar plot for the different players with the with the draft picks. We can also change the X column, wingspan. Also change this bar to 3D heat map, contour line area. This is the area plot for the wingspan and draft. We can also visualize the same thing on the Excel. Here is the chart for the height without shoe, no shoe, and wingspan, body fat. Is the chart for the height with no shoe and height with shoe. Chart for the weight and body fat decreases regularly. So, thank you.